Good afternoon, everyone. My name is Eleni. I'm the Marketing Manager at the Big Five. Today we have Mark King, Reality Capture and BIM Solutions Manager at Leica, Geo-systems DMCC. He will be talking on the topic, Digital Construction is Here. Are you ready? If you have any questions for Mark, please type them into the Q&A box at the bottom of your screens. Mark will answer as many questions as he can after his presentation. I'm just going to hand over to Mark now. Hi, Mark.
Hi, Eleni. Thank you. Hi, everyone. Good morning, good afternoon, and good evening, wherever you are in the world. Thank you for joining me today. As Eleni says, I'm here to talk about digital construction is here. Are you ready for it? As she introduced me, my name is Mark King. I am Reality Capture and BIM Segment Manager for Leica Geo-systems. I'm located in Dubai, but cover what we call the emerging markets region. So that's Africa, Middle East, and Central Asia. And I help our customers in their road to adoption of new digital technology that helps them to deliver positive changes and real world rewards in terms of profitability, efficiencies with enabling and adopting this technology. So digitalization. So this is a word that's probably been thrown around for many years, and it has some very good meaning behind it. And for me and for our organization, digitalization is about doing things in a smarter, better way. And ultimately, when we look at specifically construction or heavy construction, we're looking at ways that we can construct more safely, to ensure the safety of our staff, our employees, our people, and the people around us. We want to be able to construct on time or quicker. We want to be able to construct within our budget that we set ourselves and that we set with our customer, and also to deliver on specification, deliver what was promised, what was expected when we awarded that contract or we won that contract from our customer. So how is digitalization helping customers, people around the world in delivering on those four things? So if we look around the globe, you can see that we have things like robotics, reality capture, 3D printing, and GIS. These are just four examples of new technology, new ways of thinking that are being incorporated into today's construction to allow us to be smarter with the way we do things. When we look at robotics, it's about automation, being able to do the repeatable tasks and jobs in a much more efficient, cost-effective way, removing the chance of potential error. Today, I'm going to talk a bit about robotics when it comes to machine control, devices that control diggers and excavators. If we look on the right-hand side, we can see topics like off-site manufacturing, BIM, building information modeling, the digital twin, and machine control. Again, 4 more topics. And all these 8 topics, and there's probably more being used around the world, all form part of this move to digitalization. It's about using technology, the digitalization of processes and workflows that allow companies to be more efficient and effective in the way they deliver projects now and in the future. But actually, as an industry, are we really digitizing? You know, are we investing in digital technology? So the question is, where does the construction industry rank in terms of investment in digital technology? And this was from a study from a few years ago. They analyzed 23 worldwide key industries, and they ranked them on their typical yearly investment in digital technology. And I don't know if you'd be surprised to hear that construction came 21st out of 22nd in terms of investment in digital technology. And for an industry that has probably long underperformed when it comes to efficiency and delivering on budgets and so forth, this seems like a very, very low ranking to put construction in my opinion, and when I talk to my peers in the industry, this ranking should be much higher. You know, construction companies and the industry itself should be looking to invest more in digital technology, to modernize, to digitalize. But this is all about change, and it's about making changes within our industry, within organizations, within projects that I work. And ultimately, change is hard. It's not you can go out and buy something and change immediately happens. One of those ways we can do it is to look at new digital technology. Some of those, laser scanners or machine control devices will help organizations to digitize. You know, it's new technology, it brings new efficiency if it's used in the right way. So how do we ensure technology is used in the right way? Well, one way, and particularly one of the most important ways, is to make sure the people that are involved using that technology know what it can deliver, know how to use it, know how to get the results from using that technology. They're motivated to use that technology. They're not scared of it. You know, the robots aren't coming to take their jobs. You know, the technology is there to help them be more productive with the tasks they have today. And finally, it's the process. It's about linking the technology with the people and the process. How can this technology help the process? How can this, where do the people fit into this process that allows us to deliver on budget, on time, on specification, and safer than ever? And all these aspects play a part in this real dynamic change that is going on today in many countries and construction companies around the world. But it's certainly not easy. And for Leica Geo-systems, the company that I work for, we are very much about the value of where, the value of measuring what we have so we can manage it. And there's a very famous saying from a German professor called Peter Drucker: you can't manage what you don't measure. And for sure, that is a huge part of construction, is measuring either metrics, measuring the 3D world in which this construction building is being developed. All of this plays a part in being able to manage the data, the project, the information much more efficiently if you can measure it. And for us, it's not about a tape measure anymore. It's about using a digital technology that allows us to measure things by using lasers, by using imagery. We can measure things much more efficiently, much more accurately than ever before. So it's about moving from maybe old ways of thinking, old ways of working, an analog mindset to a more digital mindset. And as I said, this is about change, and it is as much about a mindset change inside people, inside a company. If we look on the left, you know, this person is trying to measure quite a long distance with a tape measure. You know, would you trust that measurement? You know, would you be able to understand exactly what he is measuring? With digital technology like 3D laser scanning, like reality capture, which I'll talk about a bit later on in this presentation, we digitize this process so we can actually take smart measurements, smart decisions, smart information from the site, connecting these two worlds together. And that's what we're talking about. We're talking about these two worlds. We have on the left-hand side, we have the digital office. So things like BIM, building information modeling, and GIS, geographical information systems, have been around now for 5, 10, 15, 20 plus years. And we are digitizing our offices. We're digitizing our processes in managing information in our offices and site offices to make ourselves more efficient there. But how do we dynamically connect this to the real world? Because we have this chasm of lost information where we have a digital office, but are we using that smart digital processes and that digital information in the real world? How do we connect these office and real world together to create almost a digital reality for our projects and our industry to use? And if we look at it, we go back to the point that if construction is ranked 22nd out of 23rd in terms of investment in technology, the phrase "we live in a very space age time, but we still use Stone Age tools" is actually quite an apt saying to say. You know, this is the worker of the past, but actually, you could well say that this is actually, in many cases, the worker of the current. You know, people are still using the same technology, the same information, the same processes that have been used for many, many years. There's not to say that they don't have their place in a modern construction site, but actually, can we do things better? Can technology, can processes, can new training help the worker of the future? And this may seem quite fanciful, but actually, if you think about it, this new technology isn't too far away. You know, how many projects have you been involved with now that have used a drone or a UAV to fly and capture images of the project? How many of you have used a tablet on site or a smartwatch to measure your pulse and your heart rate and so forth? And how many of you have seen a Leica Disto, a small laser measurement device that gives you very accurate measurements from the device? You know, a lot of this technology is already being used today, and it's about joining the dots between them and joining the dots between them and the digital office that now we're starting to create in the world. And with Leica Geo-systems and Hexagon, you know, we have technology and processes and workflows that allow you to connect the whole workflow from end to end. So if we look at the top, we have phase one, which is the, you know, getting the lay of the land. You know, we have technology that allows you to capture that reality. And all the way through when we start using machine control in phase four, where we're starting to sculpt the land into the area and the volumes that we need to construct our environment. Then we go to phase 6 and 7, where we start to set out or stake out and position 3D data in the real world so that we can put it in the right location and reduce error. All the way through to facilities management, where we hand over an accurate 3D as-built digital data set of your project. And all this information, even though it's on the site, it's in the field, we can connect this to your BIM GIS digital database that sits in your project core in the office. And it's a complete end-to-end workflow. And like I said, going back to why do we want to digitize? You know, why do we want to adopt new technology? And ultimately, it is about being able to deliver projects on time, on budget, and on specification. And really, if you can look at any new process, new technology, and it delivers on more than one of these things, ultimately, this will help you in the future to become more digital and be able to deliver your projects to a higher standard. So there's 3 categories that I want to talk about today, and hopefully that you'll get to learn something about new technology that isn't 5-10 years in the future. This is technology that has either been around for already quite a number of years, and actually most of this technology is now being adopted more and more all over the world to digitize what was analog workflows into more efficient, higher quality deliverables for customers. Firstly, I'm going to talk about moving dirt. And this is where I'm going to focus about a technology we call machine control. So it's maybe something you've never heard of before, maybe something that you haven't even thought of. But basically, if you think of any construction site, whether that's a building, whether you're pouring concrete, whether it's a heavy construction, you're building a bridge or a road, you are using, or the project is using, excavators, it's using bulldozers, it's using these heavy machines that allow you to move dirt, move objects around your site. And up until maybe 10, 15 years ago, this was a very labor intensive and labor focused workflow. But now, with the adoption of digital technology, if we look on the left, we had to actually show the human that was operating the machine where they had to dig. Where did they have to put their bucket to dig that hole? And this meant people had to go out and put stakes in the ground. They had to be around the machine, and the person had to visually understand where he was putting his bucket, where he was digging, where he was moving dirt or equipment around. Nowadays, with machine control, we can install inside these machines basically guidance systems, almost like a computer game. We attach sensors to the machine, and we're able to take 3D and 2D digital data into the machine. And this machine, this screen that you're seeing on the right-hand side, is basically showing the operator exactly what they need to do. Why do we need this? Well, it's ultimately making sure that what's constructed on site is exactly meeting the design. And people are actually not wasting time digging in the wrong location or spending time trying to find where exactly they need to dig, where do they need to move dirt. All this kind of thing can be shown to them on a very easy to understand screen. So what does machine control actually look like? So just as a short video, and basically, as I said, we install sensors that allow you to understand the movement of the machines. This includes GPS, GNSS, so the machine can actually understand its location in the world. In the office, you have these amazing 3D models. We can take those 3D models and actually send it directly to machines. This person operating the machine will then see the 3D model on his instrument, and even the people surrounding it helping him out. And the sensors will guide the operator to dig in exactly the right location. And ultimately, this is about efficiency and safety. Being able to guide someone to dig exactly as much or as less as they need allows our projects to save a huge amount of money and time by being much more accurate with the amount of information and dirt they're going to dig and move forward. And this is an example for an excavator, but these machines can be installed on piling rigs, on cranes, on bulldozers, on pretty much any sort of construction equipment that allows you to save huge amounts of time and effort when you're doing these huge construction projects. And it doesn't necessarily need to be huge. These can be installed on a single excavator or digger. As you can see on the right-hand side, we take data from packages like AutoCAD Civil 3D, Bentley MicroStation, any of the 3D standard packages. We can take that data, we can send it to the operators in the field, and they can actually start moving and excavating and constructing exactly as planned, saving time and effort. And really, maybe this is new to you, maybe it's not, but this is now already $1 billion market with a 25% year-on-year growth. And it really, the numbers on the left-hand side are not an exaggeration. It's about the fact that we can reduce labor on site, taking them out of harm's way. It's a 75% reduction in time, 30% fewer man hours, 35% fewer equipment. These are big numbers, and this is just because we are providing guidance to these machines that allow you to be more digital in the way they work. That the operators can be more be used in a much smarter way and be more efficient in the way they do their job. And that is a huge part of now modern heavy construction, using these machine control devices. The next one I want to talk about is called setting out or staking out. Again, this is about, we've taken our data, we now have a digital representation of our project. We want to construct that project in the real world. How do we ensure we do that? How do we take, if we're using AutoCAD, how do we take these drawings to site to make sure that we construct in the right location? If we've got 3D models now, maybe we're modeling in Bentley or Autodesk or Revit, and we want to take those models to site, how do we take them to site, and how do we use them on construction sites to make sure we construct exactly where we have to avoid any costly mistakes? And really, if we look on the left again, if we look at the analog mindset, today on most construction sites, wherever you are in the world, tapes and strings are commonly used to do this setting out or staking out or laying out process. What they're doing is essentially calculating in the field exactly where things need to be dug or where things need to be installed out in real world. And normally this is done through quite a labor intensive process of either tapes, strings, calculations. What does this lead to? Well, it often leads to a lot of mistakes. It often leads to the fact that if one of these pegs is removed, then you have to do the whole process again to do the staking out. Nowadays, with new digital technology, we can use things called robotic total stations. So these are basically devices that allow you to take digital 3D and 2D information, and you can actually position things in the real world based on this robotic total station. So in the picture you see on the right, you see a guy holding what looks like a red reflective object. This is called a prism, and basically he is being guided by the robotic total station to locate a hanger into this roof structure here. So he is now within a few millimeters locating where this hanger, this object needs to be installed. And this is all driven by this robotic total station. There's no need for tapes or strings. The total station is telling me exactly where he needs to go. So like I said before, we can take data, whether it's 2D or 3D, from any CAD BIM package, whether it's IFC, whether it's RVT, DXF, DWG. We can take that data through to our robotic total station. This robotic total station reads that information. We can then look at that and we say, okay, we want to set out or stake out this concrete floor slab. So we take the corners of that concrete floor slab, and this instrument will turn by itself. This is why it's called a robotic total station, and will lay out using a laser exactly where you need to construct your information. This is hugely more efficient than old practices in the past. I give you an example where, say you have an MEP company, a mechanical, electrical, plumbing company. They may have to install thousands of hangers, you know, the things that hold these MEP devices, and they have to locate thousands of holes on the ceiling. With this device, you can actually tell it to point at every single location so you can drill it as you go. And if we look again on the left-hand side, you know, if it's labor intensive, well, there's a high probability of errors. It's normally inaccurate and problematic. In the middle, you can use something called a manual total station, where you need 2 people to do the setting out. But actually on the far right is what we're talking about. It's the robotic total station. This device will point you exactly where you need to be. It's a 50% reduction in labor, and you'll be highly more efficient and more accurate when it comes to setting out 3D and 2D data in the field. So for example, we have on the left-hand side now a model inside Autodesk Revit. This is an MEP model, and you can see these kind of weird crosses on the top of these hangers. These are layout points. We can take all that information either via a USB or via a cloud service, and we can send it to our instrument in the field. And in the field, we can see that data in 3D, and we can use it and start setting out directly from the 3D model. We do not need to do any intermediary steps. We can start to get to the information we need so we can start setting out and laying out information on your construction site as quickly and efficiently as possible. If there's any changes, that data can then be resent to site, and these guys can then get the new information and continue setting out and not lose any downtime. So what is this increased efficiency? So on the left, if we're using tapes and strings, just on an average project, you know, maybe you can set out 200 points. With a robotic total station, at least you'll be 4 times more efficient in the way that you're setting out. You know, you'll be able to do your project 4 times faster than you could before with your robotic total station. It's a huge amount. And the fact that you're using this digital technology, it reduces your chance of human error. It reduces the chance that you've set something out or you've constructed something in the wrong location. Using the digital technology removes the human error from this process. And like I said, it uses a laser, we call it reflectorless, which allows you to show on an object or a surface exactly where that hanger needs to be drilled, exactly where that concrete slab needs to be laid. And this, the laser allows you to do this remotely, again, improving your efficiency and allowing you to do your job in a much smarter, more accurate way. And like I said before, we can connect to things like the BIM 360 cloud and allow you to draw down this 3D information, and your operatives in the field can see the 3D data and start setting out directly from that 3D information in the field, improving performance and reducing the chance of costly mistakes. And what can we use it for? So just a few examples in terms of concrete, in terms of using it in rebar, pipes, mechanical, electrical, plumbing, positioning hangers. I mean, really any sort of construction task, whether it's a building construction or heavy construction, will require some form of setting out or laying out. Nowadays, moving to robotic total stations is proving invaluable to the construction industry because it's allowing you to digitize what is quite an outdated and analog process. And as it says there, to reduce the error and cost that it takes to do this process and also increase your productivity in that process as well. The final thing I want to focus on is capturing reality. And it's about using technology that allows you to really to create this digital reality, which will connect these real and digital worlds together in a very smart and intelligent way. So again, I look on the left-hand side because traditionally, how do we measure reality? Well, we measure reality using things like tape measures, using things maybe like cameras, and we record our reality. I have a project and I want to go out there and I want to capture what does my building look like? What does my infrastructure look like? I'll go out there and capture it. Using technology, which you can see on the right-hand side, called 3D laser scanning, we can collect this information in a much smarter way than ever before. So what is reality capture? It's maybe a term that you are familiar with, and maybe it's new to you. But actually with reality capture, what can we do? So we have reality. We use sensors like photographic imagery, laser scanning, which is basically a laser measurement device, as well as thermal images. We then turn that into reality captured. We use all this technology, whether it be imagery, scanning, thermal images, to create this digital reality. We basically make reality machine readable. And why is that important? Well, 60% of today's buildings will still be in use in 2050. So what do I mean by that? Well, it means that all the buildings and infrastructures that are being used today, most of them will still be being used and will need to be refurbished, renovated, upgraded, maybe expanded over the coming 30 years to keep up with the needs of the modern people. So being able to capture reality to give to understand what actually the real world looks like so that we can digitize and create a more smarter digital construction process, things like reality capture technology would be is of great use. So we talk about on the left-hand side, we have a collection of reality capture sensors. That could be, you know, all these different things that allow you to measure, take pictures of reality, and we use that to create what's called a digital reality in the digital office, and allows you to virtually visit site and to understand what reality looks like in your project. What does reality capture actually made of? Well, for Leica Geo-systems, there's three main technologies that fall under reality capture. One is called laser scanning, and this is a device that normally sits on a tripod. It spins around, fires out millions and millions of lasers, and takes 3D measurements of what is around it. And we call that a point cloud. So basically a laser is fired out, it hits a surface, and we record a measurement. But it's not just one measurement every second. These scanners can measure at 2 million times a second. So it's very, very quick to capture a 3D data set. If we look in the middle, we have things called mobile mappers. This is a very similar technology, but essentially we mount it on a car, in a backpack. We can even have a handheld device that allows you to walk around, drive around, and capture 3D data of the environment around you. And then finally, on the right-hand side, maybe that you're more familiar with, drones and UAVs is using, airborne vehicles to capture 3D or 2D information of the world around us so we can use it in our project. And really, a combination of these things will basically capture the reality of most projects that we have around the world. So what do we actually capture? So if we start in the top left-hand corner, this is what we call a point cloud. So this is millions and millions of 3D measurements in space. So they are accurate probably to a few millimeters, and this was created in about a few hours, and we have this complete 3D data set of this environment that we've captured. On the top right, we capture imagery. This is why in the point cloud we have these colors, because we've taken a picture. In the bottom left-hand corner, we could also incorporate other sensors like thermal images. Why would that be useful? Well, we can start to understand the thermal properties or the thermal loss of some aspects such as windows or roofs when we start to capture this 3D information. We also have these things called geotags. And geotags are basically additional information that can be added to this reality capture data set while you're capturing things in the field. And these could be images, could be PDFs, could be other documents that you add to the information. When do you use reality capture? So there's actually 3 phases. Firstly, before. So before your project has really started, what do you want to do? You want to get a lay of the land. You want to understand what your road or your environment looks like, what your building looks like. So you can go out there, use mobile mapping, 3D laser scanning, and you collect this sort of type of data, this 3D point cloud, which is accurate to millimeters of the building that you are going to refurbish or renovate or to build nearby. Next we have is during. So during your construction, why would we use reality capture during? Well, actually, reality capture can be used to monitor the progress of your construction site, see what has and hasn't been constructed. It will also tell you how accurately or how correctly your construction has been put together. Is that pipe in the right location? Have they put that structural wall in the wrong location or the right location? Is that concrete slab flat? This kind of thing can be monitored very easily using this reality capture technology. And finally, where else can we use it? Well, after or near the end of a construction project, where we can use it to validate and create the as-built deliverables that customers now demand. Before we would go out and we'd create design drawings, we would then construct, and we would then amend those design drawings to deliver as built, as constructed drawings. Nowadays, using reality capture, we can go out and capture 3D data, and we can actually compare that against a design model, and we can correct the design model to create an as-built deliverable. And even the point cloud itself that you're looking at on your screen could be considered as an as-built deliverable, because it is essentially a record of your 3D reality on that day that it was captured. What can we use it for? So in this example, this is a point cloud. This is being used in a free piece of software that allows you to take measurements, allows you to walk around the point cloud that you've captured. Why would this be useful? Well, if this project was in America, I'm situated in Dubai, I want to understand how big is the opening of that structural wall, how wide, what is the area of this floor. I don't have to call someone, I don't need to visit America. I can open up my point cloud, I can virtually visit site, and I can take digital measurements. I can see in 3D exactly what that project looks like with minimal effort, minimal time, and minimal cost. And I can get these millimeter accurate measurements just by clicking a few buttons. What else can I do? Well, I can create these 3D digital records. So in this instance, we have a concrete slab. pre-pour before the concrete's been poured. Why would I want to scan that? Well, maybe I want to record for my own litigation purposes or for my own quality checking process exactly where everything has been installed. Because obviously when I pour the concrete, I'm going to lose sight of all the positions of the rebar. I'm going to lose the positions of all the ducting that have been installed. I can even add additional information and take high resolution images. I can capture all this digital data before the concrete is poured, before plasterboard walls are being put up, so that I have a digital record that I can come back to later if there's a problem, if there's potentially a legal problem, and I can tell, okay, here's my data. I can prove that I've constructed something in exactly the right location because I've got a digital record of it. It's not just the normal circumstances that we can use reality capture. This is an example of one of our scanners, the BLK 360, being pushed down a manhole to scan underground assets. Some areas are very difficult to get real world information. These scanners weigh, this one is 1 kilo, is about the size of a Starbucks coffee, and you can put it above suspended ceilings, you can invert it and scan below ground. These things give you valuable, accurate information on your reality. Using this information allows you to get accurate as-built information on your project so that you can actually design and make decisions on accurate real-world information. One of the most common things that we see, particularly with building information modeling BIM, is this scan-to-BIM process. I have a project, I need to refurbish or build something on a site. What I want to do is to go out there and scan it to create an as-built model of my existing building. So we can take our handheld scanner, our terrestrial laser scanner, our tripod mounted one. We can go out and scan this building, take it into products like Autodesk Revit, AutoCAD, Navisworks, Bentley MicroStation, anything really, and you can start modeling directly and using this as a bit like a dot-to-dot. We actually have tools that allow you to auto-fit components to the point cloud. If you scan a rectangular or circular column, we have functions that allow you to click on that column and it will automatically fit a column to that point cloud to give you accurate as-built information from that reality. Flatness and verticality analysis. This looks like a very nice picture, but this is actually a scan of a concrete floor. The colors are basically the flatness representation. And within a couple of clicks, you can scan, you can download the information, and you can create this color map, which basically is telling you that this floor is either in tolerance or out of tolerance of flatness. It's very easy to understand, and then we can use this to correct it. And this can even be done before the concrete is fully cured. It can even be wet concrete. So we can actually scan and actually analyze the concrete to understand whether it's flat. And the same can be used for elevator or lift shafts to understand the verticality of that, the lift shaft, to understand if it's correct or not. Again, this is all aimed at capturing reality to make smart decisions. It's understanding reality so you can avoid costly mistakes that may occur downstream, or for you to be able to design and project manage your project in a much better, more accurate and smarter way. Again, when we look to the validation process, this is an example of, okay, I've gone into a room, I've potentially asked a subcontractor to install this heating and ventilation system, this air conditioning system. As you can see, it's somewhat matching my design model, which may be fine. My tolerances may be okay with that, but maybe, I don't know if you've seen it, but this one is actually missing several major components of this heating and ventilation system, this air conditioning system. That is a major oversight in this subcontractor. This is something that I've picked up because I've scanned my room. Within 10-15 minutes, I've taken it into my 3D Revit model and I've visually checked it against my data. And I can see that this subcontractor will now have to do some additional work to actually meet specification. It's something that I've picked out and I've seen, and that will save my project money going forward. And again, clash detection. You know, maybe some of you are familiar with this in terms of clashing models and federating and coordinating 3D models. You can actually clash 3D models against a point cloud. You know, is my design going to fit into this space? You know, is the doorway or the opening big enough? Is my MEP going to fit into this existing building? In this case, you can see that this MEP model is going to clash with this structural beam. So it means that I have to redesign before it's cost me any money. I haven't had to prefabricate. I haven't had to send my team to site to find that it doesn't fit. I've found this before I've sent and spent any money. I can quite easily redo my design and avoid this costly mistake from happening on site. Again, another example, deviation reporting. You know, is this structure in the right location? And this could be bridges, it could be tunnels. You know, installing large pieces of concrete, I could install it, I can scan it, I can create this heat map within a few clicks. And essentially what it's telling me is red is bad, green is good. Very easy for anyone involved in that project to understand. It's not a spreadsheet full of numbers. It's a visual representation to say, is this construction, does it meet specification? Does it not? And this again is come from scanning and comparing it against your digital data that you have in the model in the office. I want to finalize on just a project that's is in the region that I'm working in, called Museum of the Future, that's based in Dubai. If you're in the region, maybe you've heard of it. If you haven't, the quick explanation is basically this is a 10 or 10-story museum exhibition space that is close to being finished in Dubai on the main Sheikh Zayed High Street here. It's a very complicated build, as you can see. It's like an oval ring shaped, and it has these steel members that are being basically bolted together, and then a complex facade being installed on it. This is a complicated construction, and if you look on many Autodesk, Tekla, other websites, they usually use this as an example. And they used a lot of BIM and smart design technology to make sure that they've designed and coordinated this project perfectly when they went to construction. But how did they make sure that construction was correct? Well, they scanned it. So that was the picture of the Museum of the Future halfway through construction. This is a picture of the scan data that they captured at exactly the same time. And it looks like a photo, but this is actually millions of 3D points that you can fly through and navigate around, and you can take measurements from. And this was probably captured in maybe 5-10 minutes of work to capture this amount of information. So what did they do with that information? Well, they validated the construction against the design model. You know, they had very tight tolerances. They had a very accurate 3D models and 2D designs. They took their 3D point cloud. I don't know if you can see it, all this point cloud information around here. And they were comparing it against the 3D model on a regular daily basis. So they could understand where potential deviations were happening. So they can either fix them before they became a problem, or they could make changes to the design or make changes to the construction process to allow them to understand what was going on. What did they use? Well, they used a 3D laser scanner from Leica. The company was called BAM. And this is an example of, you see these purple kind of flanges, these connection plates. This is the 3D model. And as you can see, the gray dots is the point cloud. And you can see that they had very tight tolerances, and they were basically comparing the 3D design model against what was actually constructed on site. So as soon as a steel member was bolted into place and welded, or before it was welded, sorry, when it was put in place, they would scan it, they would compare it against the 3D model, they would make some slight adjustments, and then they would weld it. And they did this for every single component to make sure that it was in exactly the right location. The reason being is they knew if one of these components was out of alignment, the longer the project went on, the bigger the problem would become. So their tolerances were very tight, and this was perfect for 3D laser scanning. But it wasn't just the outside that they scanned. You know, they wanted to make sure that all the mechanical, electrical, plumbing, heating and ventilation system was accurate, was in the right location. So what they did is they took one of our other scanners, our BLK 360, our smaller lightweight scanner, and they would scan the interior of the museum. And they would basically validate the location of all the installed MEP on a regular basis. And basically they wanted to understand whether their subcontractors that were installing the MEP were putting it in exactly the right location. Because what tends to happen on construction sites is these may not be installed in exactly the right location. Then another subcontractor 1 or 2 weeks later will come in, and the design has told them to put it there, but they can't because a previous trade or subcontractor has put something in the wrong location. They wanted to avoid the cost that incurs on every project. So what they did is they scanned on a regular basis and would basically tell their subcontractors whether they were on spec or they had to make adjustments to what they had done on site. And really, this was a huge success for them in terms of making sure that the museum structurally came together and that all the MEP was assembled and installed in the right location, in the right time, and on the right specification. With that, I'd just like to come back to one of my first slides, which is about change, and say that hopefully you've seen a few examples of new digital technology that is already being used today by many companies around the world. That was just one example of BAM construction in Dubai. But really, it's not just about the technology. All those projects and the companies that maybe I've mentioned, you know, we support and we've helped them deliver change through training, through helping them and supporting them in the process. And really, just buying the technology is one thing, but it's about how you allow people to use that technology, be motivated to use that technology, and then making sure that the processes are there to be able to use what that technology can give you. And really, with all those three components, it really can deliver that digitalization, that digital construction change that is already here today, that hopefully our industry will adopt more and more going into the future. With that, I'd like to say thank you for watching. I think I finished about on time, so we've got enough time to do some questions. And I'll quickly have a look through. If you give me 10, 15 seconds, I'll have a look and see if I can answer one or two of them. Okay. Does reality capture have a different meaning from laser scanning and point cloud method for capturing as existing condition? So does it have a different meaning? No. Okay. So reality capture is a kind of overarching name. It's basically any sort of technology that allows you to measure the real world, measure the environment. For Leica, we categorize that as using laser scanners, mobile mapping, and UAVs. And so all of this can be used to measure existing conditions. So there isn't really a difference in terminology there. Okay, how will digital construction help in the distribution of labor and assess their productivity and quality of work? Well, one of the main things with all kind of digital and digitalization is the fact that things are recorded. You know, I've gone to many construction projects and construction companies, and quite often things are left behind or forgotten because they haven't really been digitized. With many of the digital technologies, whether that's BIM, GIS, or reality capture, you are creating a digital record. So not only should you use it for that project, but you should use it as an assessment tool for the projects ahead. You know, what went right, what went wrong. And ultimately, you know, using this technology allows you to assess the productivity and the quality of people's work. You know, if we look at machine control, those machine control systems can actually monitor, you know, how much dirt has that operator used compared to another operator. And it's not to say one is better than the other, it's to say, how do we improve our workers so that we can be as peak optimization as possible? So being able to measure it, as I said in one of the first slides, it means we can manage it and we can assess it better going forward. Hopefully that answers the question. We've got a lot of questions, so I'm just trying to skip through a few so I can get to some of them. Okay, how much does these robotic equipments, how many robotic equipments are needed to complete a whole building? How much does this cost for the design, building, considering facilities management? Okay, so I'll take that a bit at a time. So how many robotic equipments are needed to complete a whole building? So let me take it step by step. Machine control. That very much depends on the size of your project. The more machines you have, the more machine control equipment that you might need. But actually, if you think about it, if your machine is more efficient, you will actually end up using less machinery than you had maybe initially intended. If we look at the robotic total stations, how many do you need to construct a building? In my experience, you know, again, it's hard to say, but probably for a normal building, you know, you're talking a few, 2, 3, 4, 5, depending on the complexity of the building. Because what tends to happen with robotic total stations, you may have a concrete contractor. Someone's gone in and will be doing the concrete. You need to set out that information before they do the concreting and so forth. So actually, in most cases, if we look at examples in Dubai, most major buildings will have 1 or 2 robotic total stations on their project. But then when things become more complex, they may bring in more robotic total stations as the project becomes more complex. How much does the whole kit cost? That's hard to answer. It depends what kit you're talking about, and depends what your what package you're thinking of. But to give you some rough understanding, something like one of those small laser scanners is something around $20,000, which may sound like a lot at first thought, but actually, if you think about it, how much did that mistake cost you on your last project? So it's kind of for scanning or that kind of thing is that kind of cost. Okay, can these laser scanners be used to do a structural audit of a dilapidated building? Can we generate a structural audit report? So again, 2 parts. Yes, it can be used to capture your dilapidated building. I'm not 100% sure what is in a structural audit report, but I'm guessing it's to do with the conditions, probably the location and sizes of certain things. What laser scanning gives you is basically a 3D data set. What you want to extract from that can be extracted. So if you go to site and you do a structural audit report using a tape measure or a disto and maybe a camera, most likely you will be able to generate the same deliverable much more accurately, digitize it using a 3D laser scanner. So hopefully that helps. I don't know what a structural audit report is, so I'm guessing you probably could do something. Whether it's the full thing that you're wanting, I'm not 100% sure. I'm just going to scroll through again. Okay, someone's asked, can your scanner capture materials below the earth before construction, like minerals, rocks, underground water, soil profile? No. Scanning or 3D laser scanning and mobile mapping doesn't penetrate the surface. So it only scans what it can see. So if you have a wall, it will only scan and measure the surface of that wall. We do have technology that's called GPR, ground penetrating radar. It's not typically used to identify minerals and rocks and underground water. It's normally used to identify obstacles buried below the surface. So ground penetrating radar, or GPR, is used to identify water mains or electrical cables, so that during construction you don't get your machine to dig through it, or you don't cut these kind of main utilities. You can use GPR to find some of those materials that you're talking about, but it's mainly to identify objects below the surface. So in answer to your question, the scanner doesn't, but we have other technology that can penetrate the ground. Okay, how long do you think until this technology can be ready to be deployed in developing worlds like Nigeria? If I would say we're already selling equipment to Nigeria, I'm not saying it's in huge numbers, but we are currently selling all this equipment that I've just mentioned is already being used in some way in Nigeria. And actually, if I look at the trend, and I've been in Dubai now for nearly 3 years, in the last 18 months in Central Africa, we've seen a big rise in interest and adoption of this sort of technology. It's obviously nowhere near maybe UK, USA, Dubai, and some of these other countries, but it's the growth is very large. So it's on its way. If you're interested in looking at it, please get in touch. My email address and Twitter and LinkedIn are on there, so I'm happy to accept any messages if you want to talk about or have a conversation about this technology. I've got 5 more minutes, so I'll try and answer a few more questions. Okay. Does your Leica laser scanner have a GIS system to merge point cloud models accurately rather than using target method? And the answer is, if I understand the question, yes. Basically, how our scanners work is essentially you set up your instrument, you scan, you capture 3D data. Because it can only capture what it sees, if you have a room, another room in a building, you obviously have to move your scanner to capture that other information. How do we join those together? We call something called cloud to cloud. So which is what I think you're talking about, where we're stitching point clouds together. If you want to know more, please reach out to me. I'm happy to have a call with you to talk about how we scan large buildings and large infrastructure. And ultimately, it's very, very simple these days. The technology does a lot of the work for you. Is there any example of disaster by technology integration anywhere in the world? That's a good question. I mean, I'm sure I would say I would put it in the fact that I have seen it where a company has invested in technology, but has ignored the people and the process, which has meant that that technology has failed. Basically, I wouldn't say it was a disaster, but I would say it's buying the technology is probably the easiest part of the process. Actually getting people to use it effectively, putting it inside your organization, having them use it effectively is harder. And that's the hardest thing to change. So rather than it being a disaster, I mean, this is why I mention it. So the technology never normally causes the disaster. It's normally the fact that the people in the process aren't there to use it, which is mean that maybe the purchase wasn't the best that it could have been. Okay, how many softwares do we need to use to cover the whole laser scanning process? So in simple terms, if you have a scanner in the field, a 3D laser scanner, we have an Android iOS app that controls that scanner. So you can actually see the scan data in the field using this app. We have a processing software in the office. You download your data and it processes the data for you. It's then ready to use. You can use it inside AutoCAD, you can use it inside Revit, you can use it inside ArcGIS, whatever 2D, 3D package now. Either we have a plugin for it, or it already is able to use point cloud data inside it. So really, it depends what you want to do, but really it's only one piece of software to get to a finished point cloud. Then you just need the software, whether it's CAD, BIM, GIS, to actually start extracting information from that data. With that, I'm going to answer one more question. Wow, there's lots of questions. Okay, what is the cost? Okay, will you give training for using this technology? What is the cost of all the basic equipment? So yes, we give training. So we sell in some countries direct, but in most countries we have dealers as well. And basically, if we sell technology or our distribution network sell technology, they provide training with it. So we never sell equipment without training. That is always part of it. As I said, people and process. And what is the cost of the basic equipment? Well, it really depends on what equipment you're talking about. If you do want to know the cost, then please reach out to me via email, via social media, and I'd be happy to give you a call and we can talk about what exactly the technology you're interested in adopting. I guess with that, Eleni, it's 3 o'clock. Maybe I hand it back to you to close up.
Yeah, I think that's all the time we have. Thank you so much, Mark. That was really, really valuable. I think everyone found it really good. Just to let everyone know that we will be sending the recording of this webinar and Mark's presentation to you via email. So just look out for that over the next couple of days. Thank you very much, Mark, for your time.
No, thank you. Thank you for having me.
Yeah, for attending. Thank you.
Thank you, everyone. Have a good day. Appreciate you coming. Bye-bye.